right, let's talk about equations. Remember, equations are like a balance. Whatever's on one side of the equation has to have a value that balances out that equation. It has to be the same value. It might not look the same, but it has to have the same value. An equation that you know might be something like this. 2 plus 3 equals 5 is an equation. 2 plus 3 has the same value as 5. Algebraic equations are no different, except that there are some unknowns thrown in. So the problems that you're solving today look like this. This is a balance. The center of the balance is the equal sign. So you're going to think about, what do I have on one side? Over here I have 1A, 2 A's. I have 2 A's. The center of my balance implies equal. And on the other side I have 14. It doesn't matter if they look the same, excuse me, but they do have to have the same value. So we know that 2 A's equals 14. Now I need to solve this problem so that I know the value of 1A. And I bet a lot of you can do that without even doing anything. You can look at this and say, oh, A is equal to 7. But I'm going to show you how we do that. We use the inverse operation, and right here I have 2 times A is equal to 14. So I'm going to use the inverse operation, which is division, and I'm going to divide this side of my equation by 2 because I want that A all by itself. If I divide that side of the equation by 2, I also have to divide this side of the equation by 2. 2 divided by 2 leaves me with just A is equal to 14 divided by 2. So A is equal to 7. Let's do another example. On this side of my equation, I have n and 5. I don't have 5 n's, so it's not multiplication. I just have an n and I have a 5. On the other side of my equation, remember the middle implies equals. On the other side of my equation, I have a 15. My job to solve this is to get the n all by itself. So I need to use my inverse operation. Inverse operation from addition is subtraction. So I'm looking, where is my variable? What operation is being used? And I'm going to use the opposite one. So subtract 5, which means on the other side I also subtract 5. 5 minus 5 is nothing. I'm left with n is equal to 15 minus 5. N equals 10. In this problem I have a b and a 1. So I've got b plus 1 is equal to, I've got a 5 and a 6. Not 5 times 6. I don't have 6 5s or 5 6s. I just have a 5 and a 6. So I'm going to look, where's my variable? It's right here. What operation is being used? Addition. So I need the inverse operation. I'm going to subtract 1 on this side, which means I'm going to subtract 1 on this side as well. So now I'm left with b is equal to 5 plus 6 minus 1. b is equal to 5 plus 6 is 11, minus 1 is 10. And your last example, don't let fractions scare you. On this side I have a g plus 3.5 is equal to 7.5. Fractions are numbers too, not a big deal. I'm going to look and see, where is my variable? Here it is. What operation is being used? Addition. I'm going to use the inverse operation and subtract 3.5 from this side, which means I also have to subtract 3.5 from this side to keep my equation balanced. I'm left with g is equal to 7.5 minus 3.5. 7.5 minus 3.5 is equal to 4. I hope that helps you with these problems. Good luck.